Welcome to each and every one of you. It is a great honor for me to open this presentation panel with a talk about darkening beetles. Please notice that this presentation has two authors, so me, Marcin, and Ryan. We are both researchers representing Aaron Smith's Insect Biodiversity Lab at Purdue University. This year we were quite successful in reaching out to the Coleopterists Society with our research ideas, and as a result we have received the Bell Research Award, and additionally Ryan has won the Edward Prize for the paper entitled Molecular Insights into the Phylogeny of Dabstinina. Although the title of this presentation is fully convergent with the one of our Bell Research Award, during my talk I will try to explain what is the relation between those two seemingly unrelated projects, because as you can see they both concern different darkening beetle tribes. It all started a few years ago when I received a grant from the Polish equivalent of NSF to study the phylogenetic relations within the darkening beetle tribe named Pedinini. As you can see, at that time the tribe grouped 7 subtribes. Morphological definitions of majority of them were mostly based on the structure of male terminalia. For example, we had Dendrina, which members has bipartite adagal tegmina with an elongated base, contrary to Pedinina, which also possess bipartite tegments, however with short basal pieces. And on the other hand, there was Melambina with unipartite tegmina. Sometimes the definitions were distracted by cases like this, when it is hard to distinguish between the unipartite and bipartite options. The relations between the subtribes were unknown before my study, as the phylogenetic work was had never been conducted on the tribe. I have referred to available literature and selected Opatrini and Helopinini as potential outgroups. In the case of the first tribe, so Opatrini, a close relation between this tribe and Pedinoid beetles was postulated by many authors, while in the second case, Helopinini, there were only a few remarks scattered throughout the literature. The conducted phylogeny proved fairly reliable trees in terms of the branch support and the convergence of obtained topologies with molecular morphological data. For example, the members of Erinotina and Platinotina, here marked with orange, were known to both possess stridulatory gula, therefore a sister relation between those two entities seemed to be highly probable. On the other hand, there were a few surprises, of which the biggest one was the recovery of Helopinini representatives deep within Pedinini. We used the results to propose changes in classification. You can see our little Helopinina here. Additionally, there were some fascinating biogeographic consequences of our study, like, for example, distribution of Dendrina. We are still investigating this issue. I hope that the publication about this will soon be ready for submission. However, from my perspective, the most fascinating thing was that we have opened the taxonomic black hole, which has nothing to do with wastebasket taxon. I defined that black hole here as initially small but monophyletic taxonomic grouping, which after its designation starts eating up other closely related taxa. Namely, after this analysis, I have added up the diversity of pedinoid beetles. It was about 1,000 species. You have to know that at that time, the newly reinterpreted tribes were part of the subfamily Tenebrionidae, which was proved to be polyphyletic by several authors. So if we assume that Tenebrionidae groups about 8,000 species, we have to admit that we have just found a solid, because supported by morphology and molecular data, piece of monophyletic matter within this taxonomic junkyard. Furthermore, when we investigate the available literature, as noticed before, we instantly see that several authors postulated a close relation, or close or even sister relation, between Opatrini and Pedinoid beetles. It is interesting in this context, as Opatrini groups over 2,000 species and 117 genera. We looked into this relationship and informally proposed the opatrinoid clade. At the same time, we have fed our little black hole a little bit. Here, within so-called opatrinoid clade, you can see both Helopinina, our Bell Research Award group, and Blabstinina, Ryan's Edward Prize subtribe. But as some of you probably noticed, the taxonomic background used by us wasn't really representative in order to fully test the relation between opatrini and pedinoid beetles. Therefore, we designated a follow-up study. Prior to going into the lab, we looked at some older literature contributions and noticed even bigger concept than opatrinoid clades, such as opatrina and Blapimorpha. Both concepts had some huge fans and opponents. You can find some details about that in works of classical works of James Watt, John Doyen, and Gleb Medvedev. In order to test those concepts, so concepts of opatrina and blaptina, we have conducted a phylogenetic analysis with inclusion of the species representing 27 Tenebrionidae tribes from different subfamilies such as Tenebrionidae, Diaperinae, Pimelinae, Aleculinae, and Lagrinae. You can find the results, detailed results of this investigation in our recent systematic entomology paper. But long story short, based on the results, we have reinstalled Blaptina as a separate subfamily. As you can see, during this journey, we have fed our initial taxonomic black hole quite significantly. The newly reinstalled subfamily is pretty diverse, in my opinion, in terms of morphology, and connects this year's Bell Research Award and Edwards Prize quite nicely. But let's go back to Helopinina. Up to now, our research seemed like smooth sailing. So high branch support, convergence of morphological and molecular data, and so on. However, as usual, we had some problems. The biggest one, in my opinion, concerned the fact that relations between the pedinoid tribes were largely influenced by the included phylogenetic context. Under some circumstances, there was a strong tendency in both Bayesian and maximum likelihood analysis to cluster Drosophorus of Helopinina with Leichenum of Leichenina. So this is the bottom tree. Both taxa were the most apomorphic lineages within Pedinini, which might suggest a bias caused by the long branch attraction. In order to test those topologies and select the more accurate one, we have looked at the morphology of both adults and larvae. However, depending on the character set, both Leichenina and Helopinina were extremely apomorphic. We just couldn't find any legit snapomorphies to link them together. Therefore, we sustained both entities as separate subtribes. However, in order to fully or truly resolve the relations within this tribe, a new phylogenetic analysis, probably based on more comprehensive molecular data, is needed. Furthermore, a more diverse set of pedinoid members should be included to significantly challenge the status of Helopinina. There is only one problem with that. Species and sometimes even generic level identifications within the subtribe are really challenging. Just please take a look at our trees and the IDs that we have for Helopinina. We have actually a ton of ethanol preserved specimens that we could potentially add to this phylogeny, but what is the point when we are not able to provide any generic, like reliable generic names? Here is a perfect example on how the currently defined genera are in need of revision. The majority of the generic concepts among the subtribes are based on the number and visibility of elytral rows, which seems to be not holding up pretty good. But as they say, there are no disasters, only opportunities. So let's have a look at the bright side. So the most comprehensive revision of the beetles currently classified within Helopinina was made by Carlo Koch. And here is my favorite quote from his publication. Altogether, about 7,000 specimens were examined from the whole of sub-Saharan Africa. These were kindly placed at my disposal by many European, African, and American institutions. Of nearly 300 species, which proved to be new to science, the greater part will be described in subsequent papers. As Koch stopped working on the group right after this publication, a few questions emerged. What happened to this material, and what about those 300 new species? Koch was a researcher based at the Ditsong Museum in South Africa. He was also the founder of the Gobabeb Research Station in Namibia. In recent years, I have visited the Ditsong collection several times, and due to help of Ruth Miller, I was able to play a bit with Koch's Helopinina material. And what I found was pretty amazing. In general, the identified material includes 45 fully packed and labeled drawers, just like the one presented here. So at your disposal, you have the types of majority of the species and conspecific individuals pinned right next to them. But the most amazing thing is this: sorted and ready for description, sometimes even named as new species of the subtribe. To be honest, I haven't counted if there are actually 300 of them, but there is a lot. And besides this, there are about 10 drawers of unsorted Helopinina specimens, yes, which were collected by the museum personnel after 1958. So immediately I wanted to put this material into a test. So I have used my free weekend during one of my visits to revise the genus Anaxius. It was just cherry picking, as this genus is highly apomorphic and its representatives can be easily sorted out even microscopically from the other Helopinina. So to sum it up, I had the types, I had the literature, Koch's private library and his publications, and large amounts of unsorted material. After 2 days, I finished my work and discovered 4 new species and proposed 1 new synonymy, and later published the revision with inclusion in the identification key to all of the treated species. However, I knew that the first step to a comprehensive treatment of this material is a species catalog. The last count of the diversity was done in 1943. So Gebbin had no chance of including Koch's taxonomic work, while additionally he listed several genera which were later transferred out of the tribe. This is also worth taking notice, why so many prominent entomologists had made mistakes and confused unrelated groups with Helopinina. Together with Ryan, we agreed that Helopinina is a good material for the Bell Research grant, as besides the science involved, the project will generate data on the type specimens of the group, which might result in discovery of some forgotten type materials, because at least some of the specimens loaned by Koch in the 50s are still at the Ditsong collection. The specific goals of our projects are listed here. Our key assumption was that we would go to the Ditsong Museum. However, the global pandemic disrupted those plans a bit. In order to efficiently overcome this obstacle, we reached out to some of our colleagues and form a research group. So Ruth agreed to take photos of the type specimens hosted at the Ditsong collection. Kojan is guiding us through taxon works. Gerard is a specialist working on helopinoid beetles, especially the genus Amatodes, and Aaron is verifying and contributing data to the catalog. As you can see, our catalog includes label information and status of the type specimens, distribution, short taxonomic history, and in other cases, synonyms of all species named within the subtribe. At this point, our work on the catalog is nearly finished and the catalog is nearly ready for submission. We have filled over 55 pages of standard manuscript, and that includes introduction, M&Ms, catalog, and literature. Additionally, we have about 16 full-page plates. Altogether, we have cataloged over 230 species and subspecies divided over 13 genera. The most diverse genus is Microanterellus with over 70 species and subspecies. On the other hand, we have reported 2 monotypic genera. According to our data set, distributional data set, which included over 500 distributional records, Helopinina is mainly Afrotropical. In our catalog, we will also include some basic metrics or statistics for future researchers. As you can see, mainly to Koch's work, Ditsong Museum hosts the largest number of type specimens representing the subtribe. However, the majority of the type material concerning the type species of generic level taxa was described in older contributions and is scattered through different European collections. So it's not so easy to revise this group. You cannot go only to Ditsong Museum, you have to visit other collections. Here are some types photographed by root, and to sum it up, the goal of our research project here is to open up the Helopinina to a wider spectrum of researchers by summarizing the available nomenclatural information and providing initial identification tools. We believe that this is important and that the group can be used for various types of evolutionary studies because, for example, despite not being the most species diverse subtribe, Helopinina are one of the most morphologically diverse groups within Blaptina. Throughout the history, it was noticed that some of its members highly resemble many of non-related Tenebrionidae groups, such as Amarigmini, Desmini, Acidini, Sepidini, and already mentioned Dendarini and Platinotini representing Blaptina. From a preliminary overview done by us, it can be concluded that this resemblance concerns sets of both co-occurring and allopatric species. This similarity has never been subject of a targeted study, and its evolutionary origins remains unknown. So once we will finish our work on the catalog and provide a first phylogeny of the group, maybe we will open up this awesome group for other researchers, or maybe we can be involved in that study because I personally believe this is a really nice and interesting group of beetles. Thank you very much for your attention, and thank you very much for your support. I personally think that the grant opportunities and awards provided by the Coleoptera Society are awesome and much needed. So thank you one more time, and greetings from Warsaw, Poland. Bye-bye.